This video is for Algebra 2. We're going to build rational functions today. In other words, we're taking what we've learned about holes and vertical asymptotes and horizontal asymptotes, and we're using them the opposite direction. We've been breaking things down and finding the hole, the vertical asymptote, the horizontal asymptote. Today we're going to be given that, and we're going to build things up to make the actual rational function. So if I have a horizontal asymptote of y equals 0, I know that the denominator had to be bigger. The degree of the denominator had to be bigger. If I have a vertical asymptote of x equals 0, I know that you have to have an x in the bottom of the fraction. So I know that I have to have an x in the bottom. I know that the degree of the denominator has to be the biggest. Well, the degree of x is 1, which means the degree of the numerator must be 0 or there is no x. Now, what number you put up there, totally up to you. It doesn't matter. You could put 3 over x, and there you have it. On the next one, I have a horizontal asymptote of y equals 0. So once again, the denominator has to be the bigger degree. We have vertical asymptotes at 2 and negative 4. So the denominator has to have an x minus 2 and an x plus 4. You're always going to use the opposite signs when you're doing this, because remember, to find the vertical asymptote, you take the denominator, you set each factor equal to 0 and solve. And so if I moved the 2, x minus 2 equals 0, it would become x equal 2. So as you're writing your actual answer, you want to go ahead and distribute. We're building things up today. So this would give me x squared plus 4x minus 2x minus 8. The 2 in the middle are going to combine. So on the bottom, I have x squared plus 2x minus 8. Since the denominator has to be bigger, I have an x squared in the bottom. I can either have an x in the top or just a number. Okay, it doesn't really matter what you put in the top. You could have put 3x, you could have put 8x, you could have put 2. All right, there's more than one correct answer on these. Okay, as long as you've met the rules or the conditions that you're given, the actual answer could be different for everybody. So you're done with that. Okay, on the next one, my horizontal asymptote is y equal 1. Anytime you have a horizontal asymptote that's y equal a number other than 0, that means that you had the same degree and you had to make a fraction. Your vertical asymptote of 4 and negative 3 means your denominator is going to have x minus 4 and x plus 3. So as you're building here, you want to distribute x squared plus 3x minus 4x minus 12. So on the bottom, you're going to have x squared minus x minus 12. On the top, you've got to have whatever your largest degree was in the bottom because of this horizontal asymptote. So I have to have an x squared up here. Now, you have to have, so that your leading coefficient, that's the number in front of each of your x squareds, when you make it a fraction, reduces to 1. So what over 1 reduces to 1? 1. So you just leave it like this. Going to the back, we have lots going on. When you have a hole, remember that meant that something canceled. So if my hole is at 3, that means I've got to have an x minus 3 on the top and on the bottom. If I have a vertical asymptote of 6, that means I have an x minus 6 on the bottom. And if I have a horizontal asymptote of y equal negative 2, that means my degrees have to be the same and my fraction has to equal negative 2. So what I would do here is I would multiply on the bottom, x squared minus 6x minus 3x plus 18. So my denominator is x squared minus 9x plus 18. On the top, I've got to be careful about what I put there. It has to have an x minus 3, but look at what's in front of my x squared on the denominator, 1. When I put something over 1, it has to equal negative 2 when it cancels or reduces. So don't you agree you need a negative 2 up here? This is to fix the horizontal asymptote. So I'm going to need it to be a negative 2x squared. I can't, so I put a negative 2. I also need it to become x squared, so it needs an x also. Distribute that, and you get negative 2x squared plus 6x for the top of your fraction. Okay, looking at your next one, you have a whole at negative 1, so that means you have an x plus 1 in the top and the bottom. You have a whole at 3, that means you have an x minus 3 in the top and the bottom. And you have a vertical asymptote of 1, which means you have an x minus 1 in the bottom. So if I multiply these together, it is x squared plus x minus 3x minus 3, so that would be x squared minus 2x minus 3. That has to get multiplied by x minus 1. So you've got x squared minus, no, x to the third minus 2x squared minus 3x minus x squared plus 2x plus 3. So, bottom of your fraction, x to the third, negative 2 and negative 1 is minus 3x squared. Negative 3 plus 2 is minus x plus 3. When you multiply the top, you ought to get the same thing as when you multiply it on the bottom, which is x squared minus 2x minus 3. But you have a horizontal asymptote of y equal 2. So this whole thing has to get multiplied by 2. No, it doesn't. It has to get multiplied by more than 2. We have to have the same in the top and the bottom. I have an x to the third in the bottom. I have an x squared in the top. So it needs another x. So it's going to get multiplied by 2x. 2 to fix the 2 over 1, and x to get it to an x to the third. So this becomes 2x to the third minus 4x squared minus 6x. This is your function that you just built. Last one, it's a simple one. There's just one thing. You have a vertical asymptote of negative 4, which means you have an x plus 4 in the bottom. They didn't tell you anything about a horizontal asymptote. This means that there must not be one. And for there not to be one, the numerator has to be a larger degree, which means it has to be larger than x to the first, so we can just call it x squared. You could put 3x squared, you could put 5x to the fifth, okay, anything bigger than x to the first, and it doesn't matter number-wise. I'm just going to go with simplicity here. Okay, so that's all there is. We're just doing things the opposite way. We are using the vertical asymptote, the horizontal asymptote to build the function. That's all the notes. If you have questions, call me over.